All right, number 6, we have two rate functions. So it's important to understand that this is the rate at which fish are entering, and this is also a rate at which the fish are leaving. These are rates, and that matters when we answer these questions. The verbiage will relate to that. It says how many fish enter the lake over a 5-hour period. This isn't a rate, this is a number of fish. So the only way to take that and turn these rates into a numerical unit would be to integrate. So I'm going to take the integral from 0 to 5 of this function 20 plus 15 sine of pi t over 6 with respect to t. This is a calculator question, so I'm going to math 9 this. And the answer is about 153. It says round to the nearest whole number, so we're going 153 fish. Letter B, find the total number of fish. Okay, so this is how many entered from 0 to 5. Now we want the total number of fish. Well, there is fish leaving the lake. So I want to actually turn this into two integrals subtracting. I'm going to combine it as one integral, so really essentially it would be 0 to 5, and we would take that entrance, whoops, and we would subtract the leaving function. So I want to put this in parentheses. It's going to be 4 plus 2 to the 0.1 t squared. That's dt. So it's e minus L, and it's an integral because it's a number of fish. So I'm going to go back over here. We'll go math 9, 0 to 5, 20 plus 15 sine pi x divided by 6. Close. We're going to go minus, open a parentheses, 4 plus 2 to the 0.1 t squared dx. 123. The verbiage comes into play very much in letter C. You're going to notice that it says, is the rate of change in the number of fish increasing or decreasing? So it's using rate of change language twice. Okay? I want you to know that if this didn't say rate of change, if it said if the number of fish in the lake is increasing or decreasing, I would simply use these equations because these are already rates. So if it said, is the number of fish increasing or decreasing, these two equations would give us an answer. But because it brings up the rate of change, increase, decrease, now I want to actually differentiate these two. So I want to take E prime and I want to take L prime, and I want to see what those values are at 5 a.m. So I'm going to go E prime of 5, and I'm going to go L prime of 5. I could just subtract these and see what happens. I'm going to calculate them separately and just kind of explain it all. So I need the derivative of this at 5, so that's not math 9 now, that's math 8. So I'm going to go math 8. We're going to go 20 plus 15 sine pi x divided by 6. This is at 5. So the rate here is negative 6.8. Then I'm going to go math 8 x. We're going to go 4 plus 2 to the 0.1 x squared. We're going to do that at 5. And we got positive 3.9. Positive 3.9. Now, if I subtract these two, that kind of combines them together. So let me just write this down. Negative 6.802 and positive 3.921. So remember, these two functions are tied together. If I take e prime of 5 and minus l prime of 5, that connects the two functions in the manner or in the context of the lake. So I've got negative 6.802 minus 3.921. That gives me a rate of change of negative, it'd be negative 10.723. Now, so remember now, this number just simply means the rate of change of the number in the fish in the lake is decreasing. That's all it means. So the rate at which the lake population is changing is decreasing. So for letter D, and I'm going to be very efficient with the explanation here, when it asks you for the greatest number of fish in the lake, that's asking for an absolute max. Okay, so here's our thought process. The number of fish in the lake, as we've already kind of discussed up in letter B, is represented by the integral of those two functions at the beginning. Remember, if we integrate the rates, we have a number of fish. So this is the number of fish in the lake. If I want to figure out where this integral is the biggest, the fastest and easiest way to do that is to use a t-chart. Okay? An absolute max is an absolute extrema. So if I make a t-chart and I use 0, 8, and any critical values, these are my potential extrema. Okay? So here's what I did. I started with the intervals. I went from 0 to 8. So if I plug in 0, that makes no sense because then the spread of this integral would be 0. So there are no fish in the lake according to that. After 8 hours, so I go 0 to 8, what I did was I plugged in, again, I can show you. But if I just go here and hit math 9 and go 0 to 8 and type in my 20 plus 15 sine pi x divided by 6 minus, open parentheses, 4 plus 2 to the 0.1 x squared dx, I get about 81. Okay? Now, I can't get 6.204. I can't get the critical values unless I sketch the derivative of this and find where it's 0. So if I go to y equals, and according to the second fundamental theorem of calculus, that pink box is the derivative. So if I just take that, okay, there it is, and set it equal to 0. So find the roots, find the intercepts. That's a critical value. So remember, I'm looking at the derivative graph. So if this is positive, that means we're increasing, and then all of a sudden right here around 6, I turn into decrease. So if I go second calc 0 and put my blinker a little bit to the left, put a little bit to the right and solidify, you'll see that we have a critical value at 6.204. So this is the only other number in the t-chart that makes sense to plug in. So if I go back to the home screen and I go math 9 and I go 0 to 6.204 for 20 plus 15 sine pi x divided by 6, we're going to go minus parentheses 4 plus 2 to the 0.1 x squared dx, 135. So that critical value gave me my absolute max. In number 7, I have g of x being the area underneath the graph f. So here's f. So when it asks me for g of 8 is simply the area under f from 0 to 8. So I need to go over here and break this up into chunks. So this box right here is 1 by 1. This is half a box, it's 0.5. Okay, right here is negative 0.5. This would be negative 1. This would be negative 1. All these would be negative 0.5. So if you add all that up right there, that's just a triangle that's 4 by 2. So 4 times 2 divided by 2 is negative 4. This is all negative 4. And then we're back up here to 1.5. So I've got 1.5 and 1.5 is 3, and then minus 4. This is an area of negative 1. So g of 8 is negative 1. G prime of 5. G prime of 5 would be technically f of 5. So g prime of 5 is equal to f of 5, and that's just simply the output of 5. So if I go to 5, I have an output of negative 1. That is again the output. Letter B says, on what open intervals is the graph of g simultaneously increasing and concave down? So when is g increasing and concave down? Well, if this is f, remember that this is technically g prime as well. So increasing would be positive outputs on f, and concave down would be negative slopes on f. So we're looking for positive outputs, negative slopes. Positive outputs and negative slopes. I see that in one spot, and that would be right here, from 1 to 2. So the answer would be 1 to 2, and I would say because g prime is greater than 0 and the slopes of g prime are less than 0. Letter C says list any extrema, both relative and absolute, on the interval 0 to 8. You're kind of missing something important. We want this for g now, okay? So we want the extrema for g. So again, if I'm looking at g prime, these are my glasses, right? Let's start with any critical values. So if we look at any critical values, remember extrema happen at critical values. You can see here that right here at 2, it looks to be a relative max, potentially absolute, we'll see in a minute, but right now that's a relative max because we're going from increase to decrease. Okay? Then up here at 6, we go from decrease to increase. That's a relative min. Now, if I want to figure out if these are absolute or not, I can start tracking some data, right? Because look at this. If g of 8 is negative 1, then I actually have a position. Like I actually know a location. So let's start off by determining right off the bat in a t-chart what we're dealing with here. So if I put 0, 8, 2, and 6, right? According to my first derivative analysis, these are all potential absolutes. We'll say potential absolutes. The 2 and the 6 are definitely relative. But let's see what 0 and 8 do for us. Maybe we started at the highest or started at the lowest. Maybe we ended at the highest or ended at the lowest. So these are my, we'll call them x's, and these are my g of x's. Now, in order to fill in this side of the table, I actually need to go up and get the area, right? So from 0 to 0. From 0 to 0. So if I go back to the integral and go 0 to 0, that's no area. This is 0. Now, if I go to 8, I already did that. I'm at negative 1. If I go to 2, I'm at 1.5. And if I go to 6, I'm at 1.5 minus 4, so 1.5 minus 4, this is negative 2.5. So I think it's pretty clear. Here's what we got. I see a absolute min, and that is at 6, negative 2.5. I see an absolute max, and that is at 2, 1.5. I see what you would think would be, we'll just say a relative min, but technically, see, this is an endpoint, so I can't count these as extrema, right? On the closed interval, those aren't really relative because there's nothing left of this and there's nothing right of this. So on the graph, these look like relative maxes and mins. According to G prime, that's where we're at. But because of our ability to integrate now, we can actually solidify that these are truly absolute. Again, one more time, the reason why these end up not being relative is because you don't have any values to the right of 8. You don't have any values to the left of 0. All right, this is the portion of the review that is no calculator. So it says that the area under F from 0 to 9 is 11, and then from 3 to 9 is negative 1. It wants to know which of these is correct. Okay, so right off the bat, if 3 to 9 is negative 1, then if I switch the order of these, that would be backwards negative 1, so that is true. 0 to 3, this is out of order, right? If I wanted to go 0 to 3, 0 to 3 would just be where I take this entire 11, right? So take 11 and go ahead and subtract this chunk from 3 to 9. That's 12. Okay? So if I were to switch that upside down, that would be negative 12. So this doesn't make any sense. This one, I just proved is true, right? So I wanted to say that 3 to 0 is negative 12, so that means that this is true, because again, if I want to get from 0 to 3, I would take this space and subtract this space, and that would leave 0 to 3. So that's true. So we're going with E. It says that the limit of a right-hand sum, we're written in sigma notation here. This is representing an integral, which is area under the curve of a function. Right off the bat, you can see here that the spread is 1. So I want to look for a spread of 1. That eliminates this one, right? Because that has a spread of 2. The second thing I can look at is the function. So if you look at the function, it looks like we're just taking something and cubing it, and that's it. Okay, so this is my height of each rectangle, and I'm cubing it. So that knocks it down to one of these two. But then more importantly, if you look inside the parentheses, you can always tell the first number you're going to plug in. So you can always tell where you're starting. It looks like this number line starts at 0 and ends at 1. And that's because the first, remember this is a right-hand sum, right? So I don't want to count the 0. I want to start at 1 and work this way. And so I want my last one to be this. And so that would be whatever the spread is, 1, divided by infinity. So if this is the last output, you'll see in that parentheses, you don't see like 2 plus. Or if it was this one, you would see a 1 plus that. So you'd see a 1 plus. So it's definitely not this one. It's C. Number 10. We're going to u sub this integral and just rewrite it and see what we get. So if u is x minus 1, then du is 1 dx. You can see here that we're going to have a double u sub, or a change of variable. So right now I've taken care of the square root. This would end up being u, but I have not taken care of that yet. So I'm going to go up here and rewrite u plus 1 equals x. So now I'm ready to go. So if I integrate this now, and I put du, and I put a square root of u here, I need to make sure I put that in front of the square root. And then more importantly, I have to change these limits. So it used to be 2 and 5, but now it's going to be 2 minus 1 and 5 minus 1. And so I'm looking for this. Here it is. Number 11, we're looking for the area between 1 and 4 under this function. So 1 to 4 would be from here to the end, okay? So I've got one box here, one box here. This looks to be half of a circle with a radius of 1, right? So if the radius is 1, this is pi. So this is pi over 4 and pi over 4. I think together these are pi over 2. And then this is a 0.5. So from 1 to 4, we're looking at 2.5 plus pi over 2. 2.5, plus pi over 2. So which one is equivalent to that? Here's pi over 2 plus 2.5. That's the one. Now it wants negative 3 to 1. So negative 3 to 1. So if I'm back this way, this is negative 1. This is a right triangle right here. So we're going 2 times 1 divided by 2. This is also negative 1. And then this would be 0.5. So from negative 3 to 1, we're looking at negative 2 plus 0.5. This is negative 1.5. Number 13. Using use substitution and rewriting this function. So this is very similar to number 10. So let's go u equals cosine of 3x. My du would be negative 3 sine of 3x dx. If you look up here, I don't have a negative or a 3, so I'm going to negative 1/3 the du. And when I do that, I change this side to positive sine 3x dx. And I think I've got every part. So these two things will get knocked out. And then I'll have u cubed. So here we go. If I put a negative 1/3 there and a du here, that takes care of these two things. I'm going to go u cubed. And I have to change my limits, right? So instead of 0, it'd be the cosine of 0. Which is 1. And instead of pi over 6, it'd be the cosine of 3 pi over 6. So the cosine of, that'd be pi over 2. This is 0. C. Number 14, it says that f is the integral of this function. So if I want f prime, I'm going to use the second fundamental theorem of calculus. Remember, when one of the limits is a function, we can use a formula. So f prime, according to the second fundamental theorem, would be f of u times u prime. So I'm going to use a shortcut. I'm going to take 2x and plug it in here. And then I'm going to take all of that and multiply it by the derivative of that, which is 2. So if I clean that up, I have a 2 on top, and on the bottom I have a 1 plus. This would be 8x cubed. That's D. Number 15, this is an integral. We're going to utilize long substitution, or excuse me, long division. There is no u sub that I can do to effectively eliminate all of that in a clean way. So I'm going to take x minus 2 and I'm going to divide it into x squared plus 1. Now I need to make sure that all my terms are written so that my long division works out systemically. I'm going to put an x here because x times x minus 2 is x squared minus 2x. I'm going to subtract that away. Knocks those out. 0 minus negative 2 is 2x. Drop the 1. That goes in twice. That makes 2x minus 4. And when I subtract, I have a remainder of 5. So this would be plus 5 over x minus 2. So this is essentially asking me to do the integral of x plus 2 plus 5 over x minus 2 dx. Now that I'm in a polynomial, I can check it off. This would be 1/2 x squared. So right now it's looking like it's either B or C. This would be plus 2x. We're still intact. And this is just 5 ln of that. So it's C. And then number 16. Number 16, we're going to u sub this to integrate. So I'm going to go u equals x squared plus 9. That would make du equal to 2x dx. I don't have a 2, I only have an x in the dx, so I'm going to 1/2 this du, and that will make my x dx. Here's my rewritten integral. I would put a 1/2 in front and a du here. That takes care of these. And then I just have 1 over the square root of u. Now remember, I need to rewrite these limits with respect to u, so 0 squared plus 9 and 4 squared plus 9. All right, if I were to cover this up and pretend that this is the original question, my first step would be to integrate this. So if we integrate this, right, this is u to the negative 1/2. So my integral would be u to the positive 1/2, and I'd put a 2 in front. But that 1/2 makes this 2 go away. So this is what I'm doing. So let's sub them in. I want the square root of 25, I want the square root of 9, and I want a big old subtraction between them. So 5 minus 3, that answer is 2.